Hey, Vlad here, devinsider.com. Welcome to another video. Today we're going to see 4 possible ways to encode errors in Tagless Final. Let's get right to it. Alright, now in case you're new here, you should probably know that we were in the middle of a Tagless Final playlist and quite close to the end actually. And then I wanted to make a video about error handling, and then I realized that it could be made more general. And so here we are outside of the Tagless Final playlist. If you followed the playlist, great. If you haven't, no need to worry. This video can be consumed standalone. However, I will be making a couple of references to the playlist. Alright, now quite a few times on this channel we have seen things like applicative error or monad error. In fact, a couple of months ago I made an introductory video to cats, and also in the beginning of the Tagless Final playlist we have seen the example with division, which used the monad error. So as of right now you should be relatively familiar with 2 ways to encode errors. One is where you basically hard code something like an option or an either a validated or a try, and the other one is where the DSL is completely unaware of the things that the interpreter might require, because remember, power to the interpreters, and so the interpreter can decide that it would use something like applicative error or monad error. That said, we haven't seen much of error handling so far, and the things that we have seen, we're mostly concerned with raising errors but not handling them, except for the hard-coded ones, of course. By now we know that we can fold on pretty much anything on either an option or validated or and so on. So today we're going to start with a tiny recap, and we will concentrate more on the handling side of the story. And also I have a feeling that this video might get too long, and if it does, I'm going to split it up into 2. In most of my previous videos you have seen me using a virtual machine, but recently I switched to WSL2. So I'm on Windows as a host, and I'm using virtual desktops in Windows, so I can go to Windows like this and back to the right like this, but this is still Windows with Windows terminal simply running in full screen. Alright, so I'm running in Ubuntu 18.04. Well, actually this is in Ubuntu 20.04. I forgot, in WSL2, and I'm gonna go to the dev folder, and as of right now I only have the Tagless Final project in there. So today we're going to create a completely new one. By the way, this is one of the problems that I'm having with WSL2. Well, technically with the Windows terminal, somehow there are race conditions was related to rendering of the new lines. In any case, what we're going to do now is we're simply going to use one of my typical Android templates to create a playground project, and I'm going to call it Tagless Final Error Handling. Okay, and it's going to be come dev inside you, and let's just open it with Visual Studio Code, Tagless Final Error Handling, like this. There we go. Alright, so we're going to start with just the dependencies on cats and cats effect, and later we're going to add more. So I'm just going to paste them over here like this. So we have cats core and cats effect. No, not now. Let me go to the build real quick and let's include them like this. So we're going to have org dot type level cats core. And the same thing with cats effect like this. I have a type over here, it's type level like this. Okay, so let me import the build. All right, now that I finished importing, let me open the terminal. So I have an alias for bloop, it's called just b, so I can just do b run t tab, come on, and watch. And there we go, we have our hello world, which looks like this. Awesome. So we're going to begin with a bunch of imports. So we're going to have import Scala util chaining, because we're going to use things like tap and pipe. We're going to import Scala util control non-fatal, because we're going to talk about exceptions as well. And then we're just going to import cats data, even though we're probably not going to need cats data in this one, and cats implicits. All right. So as of right now, we're just going to have this. All right, now a very common conversation in the Tagless Final circles, whatever they may be, is how to handle business errors and technical errors differently, right? And technical errors being things like, the database is down. It's basically all the things that you can't really possibly handle. Usually they're being handled by your HTTP layer, and the only thing you can actually handle is just logging them. The terminology that is commonly used for this are error channels, right? So we have several questions. First of all, how can we have several channels for the business errors and for the technical errors, and also whether we even want to use the Tagless Final style for the business errors, because as we will see, Tagless Final style sort of hides the fact that there are errors, right? Because the power is given away to the interpreter, and so if you look at the DSL, you don't even know if the error is going to happen or not. Now on the JVM, it is relatively widely accepted to represent technical errors with things like throwable. That said, Tagless Final allows you to work with throwables without actually throwing them, as we will see in just a couple of minutes. It is also widely accepted not to use throwables for business errors. We use ADTs and sometimes even GADTs for that. Now there are several ways to encode both of these error channels, and I'm going to show you 4 of them, and we're going to start with a couple of helpers. Let me actually define everything inside of the main. So the first thing that we're going to have is we're going to have a type alias. We're going to say that every technical error is merely a throwable. Okay, and we're also going to have a sealed abstract class, right? So we're going to have a typical ADT for our business errors, right? So we're going to call it business error. Let's do extends product with serializable, which is going to be come on, I can't type today. Serializable, like this, which is going to be much better in Scala 3, which I can't wait for. All right, so let's just for fun. So let's say that we're going to have like error 1 extends business error, and we're going to have, I don't know, final case class error 2, which is going to be a message of a string, and it's going to extend business error like this. Great. So another helper that we're going to have is going to be a console, and we can actually put the console outside like this. Okay, so we're going to have a console f like this. Right, it's all Tagless Final. So we're going to have good, we can give it anything, and it will just print it out. And we're going to have the same thing for bad, and we're going to have an object console, which is going to contain the interpreter. Okay, but because the type that it will return is going to be this type over here, I'm usually calling these functions DSL, right? But you can call them whatever you want. The typical thing to call them is make. Okay, so it's going to return a console of f. And for this, it's going to use cats effect sync like this, sync, and it's going to do a new console of f like this. And let's ask Metals to implement the methods for us. I did something else wrong. Object creation possible. Yes, I know. Why are you not showing this to me? What is wrong with Metals? Import. Maybe we can just restart the server. Metals is restarting. I was hoping that it would just generate these methods for me. In any case, let's just paste them like this. All right, it's awake. All right, cool. There we go. Import. Implement them for us. So what we're going to do is we're going to import the Scala console, so we don't have the name collision. And what we're going to do is over here we're going to do f.delay print line green plus and plus reset, and over here we're going to use red. All right, now in case you haven't been watching my Tagless Final series, we're using a plugin called context applied. So go to dependencies, and I'm going to search for context applied. This is what we have over here. It's right here, and the build file somewhere at the bottom, we're using it, which is over here, context applied, and we're also using the kind projector. And context applied allows us to use this f as if this was a value, right? So over here, this is a type, but we're using it as if it was a value. Okay, so just smashes together all the type classes, and then we have access to all the methods that, in this case, sync has. All right, there's an extra empty line over here. Cool. So the first way that we're going to see is very simple. We're going to use Tagless Final for technical errors, and we're going to hard code the other for the business errors. All right. So we're going to have a trait. We're going to call it error producer for some f. Okay. And it's going to have 4 methods, right? Because we always need like 4 examples. One is the example where we don't produce a technical error, then the one where we do produce a technical error, and the same couple for the business errors. So I'm going to call this one good technical, okay, which means that it's not going to fail. It's actually going to produce an f event. We're going to have, in fact, let me actually duplicate this, right? We're going to have the bad technical, and notice already you can pretty much not see that one of them is going to throw and the other one is not. Or I'm using the word throw, but it's actually, I mean, it's going to produce an error, okay? And we're going to have the same thing for the business one, good business, okay? So over here, we're going to hard code the other, right? It says either going to produce the business error or an integer, okay? And over here, you can see that there is a possibility that this method might fail, right? So we don't even have an interpreter yet, but still we're seeing that the interpreter will be forced to produce an either. Okay, so let's have an interpreter. We're gonna have object error producer, and we're gonna have DSL. It's gonna use an app, and I already know that we're gonna use an applicative error. Applicative error for the technical errors, right? Remember, technical error is just a throwable technical error. Okay, and with this information, we're going to produce an error producer for F equals new error producer for F, and Metals will generate these stubs for us. There we go. They're below, like this, and like that. All right, so a good technical error, we're using Tagless Final, so we're just going to do f.pure 1337. By the way, the star comes from the kind projector, as you have seen over here. We're using kind projector as well. All right, cool. So this is very, very simple, no errors. Okay, over here, we're actually going to produce an error. We're going to do raise error, and it's going to be a new runtime exception. And we're going to say something like, I don't know, let's just say boom. Okay. So this is a typical Tagless Final style. This is the factory method for the good values, and this is the factory value method for the bad values. All right, over here, nothing super exciting. We're just going to do f.pure, and it's just going to be a write of 1338 or something. Okay, and over here, we're going to do f.pure, and we're going to do left. Okay, business error. Let's do the second one, error 2, and we're going to say, I don't know, some business error. Okay. In fact, let's do over here something like, I don't know, db's down. Okay, so there we have it. This is the production of errors, and we have seen this actually before, right? We have seen pure, we have seen raise error, and either is just left and right. Really nothing really fancy. Okay, so now we're gonna have another DSL for the handling of the errors. So we're gonna have error handler. Okay, it's gonna be F like this. Okay, so it's gonna have 4 programs, so to say. The first one is gonna be good technical program, right? So this one is going to call, the good method, right? So the good technical method. Okay, so let me just do this 4 times. Okay, so this is going to be bad. This is going to be bad, and these 2 ones are going to be business. All right, super simple. Okay, now we're gonna go and have the interpreter for it, arrow handler. By the way, I forgot to mention this, that I'm going to upload the whole thing to GitHub, and you can look at it at your own pace. Now, I already know that we're going to need flat map, and so we're going to use monad error over here. And just as a reminder, a monad error is simply a monad, which also extends applicative error that we have over here. Okay, so we're going to say that we need a monad error, and it's going to be a monad error for the technical errors. Okay, we're also going to need a couple of parameters, right? So it's going to be the error producer of F, right? So it's, this one. And we're also going to need the console for F. And now with all of this information, we can produce an error handler for F equals new error handler for F like this, and Metals should be able to generate these stubs for us. There we go. Great. Like this and like that. All right, so the good technical program is very simple. It's just going to do a DSL, and now it's going to call, the good technical error, good technical, okay? And now it's going to flat map, and it's going to say console.good, okay? And already over here, we're actually seeing that we're not handling the error over here, and console, okay? So over here, we're not, let me actually do this. We're not handling the error here, and yet everything still compiles. And we don't even see that, there is a possibility that the error could have been thrown. And we're going to have a conversation about this in just a couple of seconds. Well, probably minutes. All right. So let me copy this, paste this over here, and I'm going to say that this is going to be a bad technical, okay? And in this case, we can leave it the same way, but I already know that it's going to produce an error, however the compiler doesn't know it. Okay, so what we're gonna do is we're gonna call a method called recover with, okay? And we're gonna pattern match on the error. Throwable and console bad throwable, right? We're just gonna log it, okay? One thing that you need to know about recover with is that it wants a partial function, and therefore if we don't pattern match on all the errors, like for example, if we say, let's comment this one out, and let's say I don't know, let's say runtime exception. Is the T actually capital? I don't remember. E like this. No, it's probably small. Runtime exception. Okay, so in this particular case, I was expecting that it would actually tell us that that we're forgetting to mention something, but it seems like it doesn't even warn us. But in any case, recover with wants a partial function, and therefore it is not recommended to use recover with. It's better to use handle error with. Oh yeah, it's actually the other way around. Like what was it? What was I saying? Like the handle error with actually should warn us about this. Um, and I have no idea why it doesn't actually. Handle error with actually wants a total function, and it's supposed to actually warn us. Is Metals broken again? Restart server. I'm not sure why it doesn't warn us. Okay, in any case, it is recommended to always use handle error with because you should get exhaustivity checks for your errors. Oh yeah, now I know why, because it's not an ADT. Exceptions are not ADTs. I totally forgot. I'll show you this later for business errors once we get to the point where we're also going to use the Tagless Final style for business errors. In any case, this is the code that we're going to have. Okay, so over here we're not handling the error, even though it's totally possible that there could have been an error. Over here we actually do handle the error. Okay, so over here we're going to do the good business error. So we're going to start the same. We're going to do DSL. Let me actually do this good business, and then we're going to flat map, right? And it's going to be an either, and therefore we already know we can just fold on an either, console bad, console good. Okay, and in fact I'm actually going to use an underscore over here, and this is how it's going to look like. Okay, super cute. Pretty much the same thing over here. Okay, so this one is going to be a bad business like this, and there we go. All right, so now it's time to assemble everything together. Let's call it handler, and it's going to be error handler, right? So this is the error handler, this one, and it's going to be parameterized with effect IO, okay? And we're going to use error handler in DSL, and we're going to give it error producer DSL, and we're going to give it the console DSL. All right, so now we have our handler, and now let's call it a couple of times. So we're going to do handler good technical program unsafe run sync, and there we go, 1337. Great. Let's just copy this, paste it like this and like that. All right, so this is going to be the bad one, and this is going to be the good business one, and this is also going to be the good business, and we're going to have the bad business. Okay, like this. Cool. Now, before we have a discussion about this, since we're having a discussion about error channels in the first place, why don't we just for fun go to actually the console interpreter and actually use the error channel that is that is designed for applications. So Scala console has an error over here. Okay, and so it is going to go to the error output stream, and Bloop shows it like this. SBT actually doesn't, so SBT would just make it red because we're using the red ANSI color. But this one was just for fun. First thing that I would like to show you is that this handle error with pattern, it can also be substituted with something else. So over here, instead of basically having this over here, well, pretty much instead of this thing over here, we can simply go and say attempt over here. And what attempt will do is it will convert an f of, in this case, f of int, into an f of either throwable or int. Okay, and therefore we can now handle it the same way as we were doing before. For example, like this. Okay, so we're attempting, and now we can do this, right? The result should be exactly the same. So if you, for some reason, don't like this syntax, you can always convert it into an either. You can also go back and forth. So if I go back to this, where we didn't have an attempt, now we can have an attempt, and we can actually go back to f from either. Right, so these two lines, they're pretty much, they're like the mirrors of each other, and therefore, because they're both there, it doesn't really matter, right? So if you comment them out, the code is still going to compile, right? So you can go from an f of int to an f of either throwable or int, and also you can go the other way around. So if you have an f of throwable and int, you can go, so if you have an f of either throwable or int, you can go back to f of int. Let me throw this out real quick right now. Another thing that I want to show you is that for some reason, if you go to error producer over here, now for some reason, if you simply throw an exception over here, and if you're inside of a map or a flat map, there's something in cats that will actually catch it for you and wrap it into this raise arrow. Now, from a purely functional programming perspective, this is a bit weird, but in practice, it's actually quite handy. Let me show you what I mean. So if I were to just grab this exception and comment this one out, and I would just throw it, okay, then it's going to explode, right? Which is not the same behavior as we had, okay? And also, if I wrap it into a pure, it is also going to explode, okay? And I'm going to show you a couple more examples. So if we do something like pure, and we're gonna create something like it doesn't really matter what we're creating, and then we're doing something like as, right, which is basically a map, it's still gonna explode, okay? But for some reason, if we use a map over here and we say, I don't care what comes in because it's irrelevant, and over here we're just going to throw, then something inside of cats is actually going to catch it for us, and it's going to wrap it with this raise arrow. The same thing for flat map like this, and then we need to do after pure over here, open paren and close paren. Yeah, we would need to monitor there over here because we're using a flat map. Okay, but that's not the point. The point is that as soon as you use map or flat map, something in cats is actually going to handle it for you, which is kind of weird. And I actually couldn't find the code that does that. And let me actually show it to you that if you simply use IO directly, let's actually go down and let's go over here. Let's say effect IO. This is going to be irrelevant. Okay, and over here we're going to do dot map, and over here we're going to do throw new runtime exception. I'm going to say db is down, okay, and we're going to run it and say front sync. Okay, so it's still going to explode. Okay, so this has to be something in the interpreters for the applicative error and for the monad error that does this for us. Okay, so let me remove that stuff. Okay, as already mentioned, like in from a pure functional programming perspective, this is very weird, but in practice it's actually kind of handy. All right, now that I have shown you a couple of tricks here and there, let's actually talk about this first encoding, right? So as a reminder, the first encoding, we're saying that for the technical errors, we're going to use the Tagless Final style, so we're going to allow the interpreter to decide what it's going to do, whether it's going to run concurrently, whether it wants to produce errors and so on. And for the business errors, we're going to hard code and either. Now, it's a typical thing that Scala beginners, they're very excited about things like option. And the beauty about option is that you cannot forget to handle the errors. And so either is pretty much the same thing. So we get the same benefits. So it looks very good, but there is always a cost in life, right? So there is nothing is perfect in this life. Now, I'm sure that many of you would argue that this cost is actually very low, and there's nothing really wrong with this solution. I'm just trying to discuss like some pros and cons, right? One of the cons is that you're always forced to actually handle this business error, right? And so if you have a couple of, I don't know, nested services, nested layers, and then you might not want to handle the business layer, the business errors in every layer, right? But because it's an either, you would be forced. You would be forced to do this, okay? On the other hand, with Tagless Final, the interpreter has all the power. And so in the DSL, you don't even see that there might be an error. And so you might forget to handle it. Okay. Now, in case of the technical errors, it's not such a big deal because usually just at the end of the world they're going to be just logged. But in case for the business errors, it's probably not such a good idea. Another sort of like a hidden cost for the business errors. Remember that Tagless Final, the whole purpose of Tagless Final was to have a solution for the expression problem, right? So the interpreter will decide later that I can't actually produce this integer. For some reason, I'm going to fail. Okay. Now with this one, it's actually the other way around. You need to know ahead of time what errors the implementation is allowed to produce, right? So you're basically hard coding this ADT over here, right? So you take a little bit of freedom away, you get something back, yeah, it's just like with everything in life, okay? Right, let's actually move on to the next encoding, okay? And for the next encoding, we're going to go like a full Tagless Final route, and we're simply going to use applicative error twice, right? Once for the technical errors and one for the business errors. And the way we're going to do this is simply by, I'm going to copy this entire file, create a new one. I'm going to call it main2, okay? Main2.scala. Okay, I'm just gonna paste the whole thing. I'm gonna go over here and I'm gonna call it main2. In fact, let's actually go and rename this one to main1. It's gonna be main1. Let me actually also rename the file to main1. Main1 like this. And okay, a bunch of stuff doesn't compile because it says that console and stuff. So let's actually have like a new file, new Scala file. Let's call it console. No, that's good. So this is gonna be, it's gonna be a trait, and it's gonna be called console, like this. So let me grab the console and just move it out, like this, like that. All right. So let's go over here. Let's remove it. All right. Import cats over here. What else do we need? All right, that's it. Cool. So now that we have console, we have the main1, we have the main2. Let's go over here and switch it to run the main, which is called dev inside you, Tagless Final. Hold on. Dev inside you dot Tagless Final error handling main2. All right, there we go. So now it runs the second one. Let's actually verify that real quick. Let's put a 50 over here. Yeah, it's this one. Great. Okay, so what we're going to do now is we're simply going to go and we're going to say over here that the business errors, the good business and the bad business, we're going the full Tagless Final route, right? So we're going to have an integer over here. And so over here, we're going to have another applicative error like this, right? So I'm just going to paste it over here for the business errors. One of the issues with this approach is that because we're using the same type class, our code is going to become less ergonomic because now we have an ambiguity of implicits, and if we're going to do like f dot, it will the compiler will not know which one to choose. Okay, but for now, let's try to do it like the wrong way. Okay, so over here now this is not an either. Okay, and below it's also not an either, so we don't need this whole right thing. Okay, and over here we don't need the whole left thing. Okay, so we're already having like a little bit of benefits. Okay, so now it's going to say that this is a type mismatch. It says I found okay, so over here we need a raise error. Okay. Okay, and so now we have the sort of ambiguity, right? So it thinks, the way context applied worked is that it just took the first one, and so it thinks that we're calling, raise error on this one, and therefore it says, hey, I wanted a throwable, but you're giving me a business error. Okay, and so what we're going to do is we're going to simply assign a different letter to it, and so we're simply going to switch to the other syntax over here. So we're going to say that this is going to be just an F like this. Like this, like that, no brace over here, and like that. Let's see, like that. There we go. And now we're just gonna have an implicit over here. I'm gonna say this is gonna be an F applicative error for the technical ones. Technical error int, and we're just gonna copy that and paste it over here, and then we're going to call it G, and this is going to be the business error. Okay, and now in these two ones we're going to use the F's, and over here we're going to use the G's, G and G. All right, and what does it say? Takes no temporal, expected 1. Yeah, that's because I did it wrong. So we need to have an F over here, G over here, come over here, come over here, and we don't need the integers. Like this. Okay, so the F is going to produce the technical errors, and the G is going to produce the business errors. Okay, what is happening? There we go. Okay, so this F is this type over here. This is a value, and this is another value. Okay, so for these two, we're going to use the Fs, and for these two, we're going to use the Gs. And for some reason, it still doesn't like me. By the way, we can use pure on the F as well, right? Because the pure is the same. By the way, why do we have the business error over here? Let's remove that. Okay. Oh, was this it? Oh yeah, that's why I just forgot to remove it from here. Okay, so let me actually close this. Okay, so there we have it, right? So we're using the applicative error twice, once for the technical errors, once for the business errors. Some of our ergonomics, went away, but there's actually a solution for this, and we're going to see this in the third encoding. Okay, so let's go back over here. So now we have the error handler, and over here we're going to handle both of the errors, right? So we're going to have the let's actually do the same trick over here. So let's what do we need? Yeah, let's cut that out over here. Let's say that we're gonna need an implicit F for the monad arrow for the F, okay, and we're also gonna need the monad arrow for the G, and that's gonna be a business error like this. So we have the F and we have the G, and over here we're losing even more ergonomics, right? Because now it's kind of lost was the ambiguity. Okay, so we basically need to go back to the good old syntax. Okay, so we're gonna do F flat map DSL good technical. Okay, and over here we're gonna do console dot good. Okay, so this is exactly the same code, just like was the old how should I call it, data driven syntax or something. Okay, so over here, okay, so we're gonna have F handle error with, and we're gonna have inside an F flat map of DSL dot bad technical, and over here we're gonna have console good like this, and now we can pretty much have the same thing over here like that. Okay, great. So let's see. So for these ones, we're pretty much gonna do the same thing, but with a G. Okay, so let's do this. This is going to be a G, and we're going to handle FLMA DSL. So this is going to be a good business, right? So it's going to be good business, okay? And over here, we're going to handle the business errors, but we're going to have like a catch-all for them, business error, okay? And it's called business error now, like this. All right, and at the bottom, we're going to do the same thing pretty much like this, but in this case we're gonna call the the bad business like this. By the way, in this case I can actually show you this recover with, right? So if I do recover with, and over here for some reason I'm gonna handle only the business error, what was it, one of them was an object, I think, like this. Okay, so like this, it just compiles, but if we use handle error with, it should give us the exhaustivity check, and it should say that we're not handling the other one, which it doesn't for some reason. I have no idea why. Maybe because we're still having errors down there. I'm gonna leave it like this, and we're gonna come come down to this. Okay, now for the effect type, we cannot just simply use IO because before we were using an either to carry the business errors. Okay, IO cannot handle both, and so we need to talk a little bit about monad transformers. And so for this one, I'm actually going to duplicate this line. I'm going to comment this out, and for this one, we're going to use an either T. Okay, either T effect IO. Okay, and let me actually do okay, for now let me just do this, and let me do that. Okay, I just want to show you that it's basically all the same information, but now I can actually handle the business error for some type like this. Okay, so it's sort of like the same thing, but there's also now an either in the mix, and it's going to carry the business error for us. Okay, so let me throw this out. Let's do this. Okay, now because this is an either T, we actually need to get the value out. So I'm going to mark all the unsafe run syncs, and I'm going to do a Control-Shift-Enter, which is going to introduce a line before that, and I'm just going to get the value out, right? So that we go back from either T to a regular either. And this is where we have it. We have our exhaustivity check over here. It says match may not be exhaustive. It would fail on the followed input, error 1. Okay, was recover with or recover error with, yeah. So with recover with, because once a partial function, it actually would work. Okay, so yeah. So by the way, this is a good example if we go and handle only the error 1, which is an object. So we need to do an add over here. Okay, so now we're not catching this, and we're also not being warned. And now the question is, where did the error go? And the error is being capped in this either, but we're just not we're not printing out the either. So what I can do is I can just tap this into a print line, and we're going to see that the either kept the error for us. In fact, maybe we should actually add this tap over here and over here and also over here, like this. All right, so in the case where there were no errors, it was a right. Over here, there was only a technical error, so the business error was a right. Over here, there was also no errors, so the business error was a right. But over here, the business error was actually a left. And so because of this, you should never use recover with, and instead use the handle error with, and it will warn you that you are not handling all of the business errors. Okay, so we're just going to do this business error. And over here, console bad, and therefore everything is handled, and therefore every time we tap, we're seeing the right. All right, now let's talk about this. We obviously lost a bunch of ergonomics, and it's our code has become like a little bit weird, but there's a way to get it back, as I will show you in the next encoding. And by the way, this video actually is getting too long, and so as mentioned, I'm going to split it into 2 videos right after this discussion, and then in the next part, we're going to see the 3rd encoding and the 4th encoding, and the 4th encoding is going to be the most exciting one because in this one we're going to use multifunctors. All right. So now we don't see we don't see that the error might be produced. Okay, the error producer says it's called error producer, right? But you don't see that the error might be produced, and therefore when you're dealing with this, remember that over here in the error handler, we're dealing with this trait, and therefore if we look at, for example, this one, bad technical, right, we're seeing that it just returns an F event. We don't see that it might fail. And so now we have the same problem with the business errors and with the technical errors. We actually don't see that they're actually happening, but at least now we have our solution to the expression problem. Which means that the interpreters have all the power, and they can decide, if they're going to throw something or not, if they're going to handle something or not. But you don't see this in the types, which is kind of ironic, right? Because usually when you hear people talk about Tagless Final, you kind of see them, talk about effect tracking, and that you see everything in the types. Well, there's a slight catch to that. You see the implementation by looking at the types. Okay, so for example, this is the interpreter, right? Because which means that this is the implementation of the of the error handler trait. And so now if you look at the interpreter without looking at the implementation, you can see that it is going to well, in this particular case, the type classes are not so descriptive, right? Because with monad errors, you can both raise errors and handle errors, right? So you don't see exactly what is happening here. Are errors being raised, or are errors being handled, or both? And also, nothing is going to force you to actually to actually use these type classes. Okay, but this is what people usually talk about when they mean effect tracking. However, it's a very subtle caveat that you see the implementation just by looking at the types. However, if you look just at the DSL, you don't see shit. You just don't. All right, so yeah, so we lost the ergonomics. We got the solution to the expression problem back, but we're not, we can very easily forget to handle both the technical errors and the business errors. All right, and in the second part, we're going to talk about how to get the ergonomics back, and also how to seemingly have our cake and also eat it too. All right, I'll see you in the next one.